I'm fixing my printer now. I'm looking to do like a 4.5 hour session here. So I think we'll be able to make some huge progress with that amount of time being committed. My YouTube video editing went really quick today. Alright, this is what I was looking for. These are little tester hook probe things. They're spring activated. They work kind of like a fishing lure. You know how fishing lures work? Like not a lure, the bobber. Fishing bobbers, you press down on the stem and the little hook comes out. And then you let go and the hook pulls back in. That's how you connect a fishing bobber to your fishing line. They're the exact same thing as that. They're pretty much a bobber. And I'm going to use that to connect to the ends of the wire. I should probably keep these in my multimeter bag, actually. So we'll get that out. I don't think I need anything else from this bag, but I could end up needing it, who knows. I'm gonna put it all away anyhow. This bag has a lot of stuff in it, I must say. But it is what it is. I mean, we need a lot of stuff. So, oh well. It's kind of cramped in here, but I guess that's fine. I think it about has everything I need. Maybe we'll consolidate it a little bit over time. There's some redundancy in here, but not too much. It's got like everything you could need to do electronics in this bag. Well, between this bag and my other box. They got it all. Okay. So the next job on my to-do list is run a paperless print and measure the two solenoid cables to determine which one is red and which one is ground, aka black. Because at this time we have no idea, and the polarity does matter for our voltage divider circuit to work properly. I find it funny how you guys don't think that I'm capable of fixing the printer when I've already taken it apart and gotten it working and done hundreds of prints on stream, demonstrating some level of proficiency already. Even if you don't believe I can build a robot, I think it's pretty evident that I'm doing a decent job so far at getting this printer back in business. I mean, this thing was in parts scattered all over my house, and I got it back up and running and working. It may need a little bit of manual assistance, but I've managed to learn everything about it and get it mostly working. So I think I've earned a little bit of credibility as far as the fixing of the printer goes. Maybe I'm not credible for robotics yet, but I think I'm credible to some degree. There should be some suspension of disbelief for sure that I might actually pull off this laser printer fix. Now, I'm 110% sure I'm going to do it, but I'm surprised you guys aren't even a little bit sure that I'm going to do it after how far I've come and how much progress I made already. That's true, I was able to print before I took it apart, but the fact that I took it apart, made my diagnosis and plan, and then put it back together, I think deserves some credit, because that indicated a level of organization and understanding of the way it's constructed. It's a lot easier to just take something apart and scatter the parts than it is to put all those parts properly back on again and then get it working once again. So I think that that should demonstrate some level of proficiency for those who think that I'm like a monkey playing with rocks and it's just not even possible that I might fix it. We're gonna connect. Well, can you guys see good enough from there? I don't know. I'm gonna connect this. Oh, look at that. Looks like little alien antennas. Kind of creepy. It's like a little slug. It looks like a slug head. So that will pull the wire into here. And then I guess we put the multimeter somewhere else. I don't know. It's just a way to connect easier, I guess. You know, actually, I think it might be easiest just to have it grab the multimeter tip and grab the wire and just pinch them together like that. Maybe that's the best way. Alright, so I'll put the red one and this guy. I think that's good. I'll show you guys what I did. I don't really know how to zoom on it. I don't know. I think they're pinched together. And now I just got to do that on the other one as well. And when I run the print, when the power goes to the solenoid, since these are splicing out of that wire, this will turn it to 24 volts. And if it says negative 24 volts, I know I got to flip it around. If it says positive 24, I know the polarity is correct, and I can mark one of these, because both the wires are yellow, so I need to mark one is black and one is red. So I'm just differentiating things. Oh gosh! Okay, I need tape. Holy cow, that was frustrating. Alright. The weight of the wire just jerked the whole thing off the table. So let's start all over. Oh my gosh. Oh, oh, oh. Gosh. Alright, I think we got it. That was a real pain. All this to take a test. Alright, maybe I can even get the multimeter in the frame. So now all I have to do is tell the printer to print a demo report. With no paper, won't matter. Alright. You guys see it? I think it said 27 volts. Dang, that happened fast. I'm gonna have to watch the replay. I don't even know. Did it show? You know what? Let me just watch it again. I'll just click the check mark. Alright. We gotta watch it. Man, that happens fast. Ah! I think it said positive, but I'm gonna watch my Twitch past broadcasts in slow motion to see what happened. Alright guys, right there. It says 20.23. $29.77, 20.23, 5.19, 5.11. So as you can see, it's definitely positive. There is no minus sign at all. Definitely not a minus sign. It moves a lot, several times, but there's never a minus sign. So we're good. It's a positive. So we got it right. Well, we didn't get it right. We tested the first try and put red on the correct one and black on the correct one. So now I can color code the two yellow cables with red and black to reflect their true DC nature. Am I on DC voltage? Yes. This is a DC power supply. It rectifies to DC from AC, and all the motors and solenoids are DC motors and solenoids. I'm measuring DC voltage. It moves rapidly because the solenoid is only switched on for a split second. Exactly. The way I have the cables right now is correct. Because it's a positive voltage, we know black is on black and red is on red. So that's the point of that test, and we ran it successfully. So that was my first job on the to-do list for today, is to identify what cable is what as far as the yellow cables coming off the solenoid. We've now done that. So I'm gonna put some red tape on the red one and black tape on the black one. Let's see. I put the tape more toward the center of the wire because I think we're going to have to cut them to length later on. They're not going to actually be that long. So if I put the tape toward the end, it would get cut off. So I'm putting it a conservative distance away from the end of the wire, so it will remain on and be visible when I go to connect this wire to my voltage divider circuit, which is going to bump the 24 volts and unknown amps down to 4 volts or 3.85 volts and a known amperage max, which will be I believe like 8 milliamps, or no, 0.8 milliamps, which is very safe for the Arduino to read in. And this line, when it activates, as we've seen it activate now, live, stop listening, live on the multimeter, we've seen it come to life, it will be the signal that will trigger the Arduino to begin turning the motor that will aid the turning of the pickup roller, which is weak due to a weak magnetic clutch. This is our power assist system that we are developing. I think I don't know. I feel like these little micro claspers worked out quite well, don't you guys? They're like 5 cents on eBay. I don't even know what they're listed as anymore, but they definitely earned a permanent place in my multimeter bag. Let's see. Okay. Very nice. So now we got these little testers taped in. And we won't lose them. We just have to remember, mental note, where we put them. They are no longer in our part bag. I consider them to be a multimeter testing tool, so that's why I put them in my multimeter bag. You want me to catastrophically fail? Well, unfortunately, I have bad news for you. I pretty much always succeed at everything I do, and I'm the best of the best at everything. So if you come to this stream to see failures occur, you're going to be really disappointed. All you see on this stream is winning. Alright, so I get to cross that off my to-do list. Another mini job bites the dust. Alright, now it gets brutal. Absolutely brutal. The next job on my to-do list is why I procrastinated even starting today. It's just overwhelming to me. We're pretty much going to be doing this job for days. Oh, it's a lot of work. Oh, that was the easy part I just did. The next one is impossible. Why do you be enraged watching me label my part bag? It's very important to be organized. There's a lot of parts that need to be mentally and physically cataloged to be a roboticist. There's all kinds of little tools and gadgets and gizmos. You gotta know where they are, what they look like, have it all labeled. Some people create little drawers all over their walls of all the little parts they have. But I don't like that because you have to get up and go get them. I like to have all my stuff in little bags. All the bags are clear, and then the bag containing all the bags is clear, so you can look in it and try to find stuff visually. I think it's a good system. And these can be stored on shelves right next to where you work, so you don't have to get up. It's more efficient. Someday my robots are going to be taking this bag off my shelf, and I'll have to tell them, hey, where's my part bag? You guys got to bring that back when you're done using it. Because they're going to be getting parts out of here to build more robots and build other stuff as well. Naughty little robots always stealing my parts. But I won't be too mad at them because they will be making me a fortune. Was the printer a failure or success? Well, I wouldn't know, would I? Because I'm still working on it right now. Whoa, that is a tiny 7805 regulator. Wow, I didn't know they come that small. That's a surface mount style one. Look at this thing. This is called an ATTiny Microcontroller. It's basically a really tiny little Arduino. It's one of their tiniest models. It has less pins than the Arduino Uno, which is their most popular model. Come on, stupid webcam. Ooh, it worked. 5-volt ground and bin. P0 through P5. You can see here the 7805 regulator right here. That is one tiny little regulator. The ones I bought were dip style. They're huge. They're like the size of this whole board, actually. And then this is where all the magic happens. This is the actual microcontroller. Everything else is just a development board. It's got various supporting capacitors and resistors and stuff all along here. I imagine it must have some kind of board that does USB to serial conversion, but I'm not sure. Oh, look at that. It's got other labels here. PB0, MISO, SCK, ADC1, ADC2, ADC3, NRES. That must be reset. That's good to know. So that will help a lot with knowing what to connect stuff to. And of course, we have here our mini USB or micro USB connector. So we can connect up to it and hopefully just program it right away. It should have an LED. One of these is probably an LED. Maybe this one? Or no, this one? I think this one's an LED. So that must be its resistor to go with LED. That LED will start blinking most likely if this has firmware on it. So it'll have, normally these come with the bootloader, the bootloader installed and the blink program installed. So it'll just start blinking when you get power into it. But if it doesn't have a bootloader, we have to bootload it. And that will require wiring this thing up to an Arduino Uno and then running a bootloader installation program. So we'll find out if we have to actually go through that process. It's a bit of a pain in the butt. I prefer it when these types of things come pre-bootload installed. Alright, so alright guys, look. It takes the same USB as my phone. You can see it's got a little light on it now. But this is just a power supplier. I need one that goes to a normal USB on the other side. Alright guys, by the way, those components I was using to connect my multimeter tip to the wire tip is called an electrical probe testing lead wire hook kit. Costs $1.17 for 10 of them. And I've now gotten my first use out of it. I bought that literally because it was cheap and it seemed like something that I might need someday, maybe. It was kind of a hoarder-ish purchase. And that paid off because I ended up using it. It helped me. Now I can begin trying to program this ATTiny microcontroller. Look how small it is. It looks like part of the USB cable. It's just this tiny little microcontroller. It's just crazy, man. The technology is just crazy. Alright, I got it plugged in. Uh-oh. Installing device driver software. Uh-oh. Dun dun dun. What's gonna happen? Wake up. How to bootload ATTiny85. Press A. Press T. Press delete. Press space. Using an Arduino Uno. Uno. Bruno. Press delete. Press delete. Press return. I'm battling internally temptation to quit early because I just feel tired, but there's not a chance in hell of that happening. I'm laughing because I see my body's tiredness as a challenge. I laugh in the face of challenges. Okay. So let me just give you guys a little overview of what we're running into here. Got some problems to overcome. I chose to use an Arduino. No, not a, well. Yeah, it's a type of Arduino called an ATTiny85, and it comes on a little development board, and it has way less pins than an Arduino Uno. As you can see here, this is an Arduino Uno, and this is an ATTiny. You can see the size difference is huge. We only want to use this little ATTiny, but I thought I could just plug in this micro USB and plug that into my computer and it would just work. But guess what? Failed to install the drivers. Why would it do that? Because it's a stock ATTiny85. It's stock. It doesn't come with, when you first buy it, firmware or a bootloader. There's nothing on it. So that's why my computer couldn't install the software for it. It didn't recognize it. So to get around that, we have to flash the bootloader onto it. And to do that, we have to follow a tutorial for that, because I don't have notes on how to do that, which I should, and I don't know why I don't. So that's kind of where we're at now. I'm going to try to follow this tutorial, and I'm going to take notes on it in the form of a Photoshop JPEG document or a .psd file made in Photoshop. So it will contain written instructions and pictures that I'll be drawing. That way, the next time I need to do this, it'll be quicker. And in addition to that, I wish to program all of my ATTiny85s. I have about 6 of them. I'm going to program them all at once, because that way we don't have to go through this the next time. They'll already have the bootloader installed, so all we have to do is just connect it up to USB and we can program it right away. We don't have to worry about jump starting it from a working Arduino, so to speak. So that's where I'm at. It's a pain in the butt, but I guess it's cool. I shouldn't complain. This is part of electronics. It's complicated stuff. There's a lot of steps involved. It's not going to take that long, console. It'll probably be done by the end of 2025. Alright guys, I just plugged in my Arduino Uno. We're going to convert the Arduino Uno into an Arduino ISP, or Arduino as ISP programmer, and that will enable the Arduino to be connected up to the the ATTiny85 microcontroller. And once we've wired all that up correctly, we can then burn the bootloader onto it. Once that's burned onto it, then my Windows computer will be able to identify it, and we can directly install sketches onto it. Installing sketches onto it is our goal. We want to install a sketch onto it that will enable us to read in from the printer whenever the solenoid turns on for the pickup roller release lever. It will send a 4-volt signal to the analog input pin of our ATTiny microcontroller, and it's going to be sending that because we're converting the 24-volt solenoid power lines through a voltage divider down to 4 volts in a safe amperage, which we've shown in a previous video. And that will enable our ATTiny85 to know when the printer is trying to activate the pickup roller system. So that's the timing portion. Once it has that information, then it will know to turn on the motor, which is going to power assist the pickup roller assembly to aid it in turning at the proper speed and power levels that it needs, and it currently does not receive due to a failing magnetic clutch system deep within the printer, which I didn't want to replace because that would be more expensive than this solution we're doing here, and it would also be higher risk because we'd be removing a bunch of stuff and it'd be hard to put it back together. So higher cost and higher risk? No thank you. I'll just do the alternative, which is to create a power assist system. Okay. Okay, now go to Tools, Arduino Genuino Uno. Okay, we already got that selected. Tools, Board, click on that, okay. It's already selected. Go to Tools, Port, click on COM6. This is the port for my PC anyways. It was COM4 this time I saw when it tried to install it, so Tools, Port, COM4. Okay. Now click Upload Sketch. This will upload the sketch to your Arduino Uno board. The board is now equipped with the tools to program the microcontroller. Okay. I clicked Verify. Now I'm clicking on... Okay, that compiled it. Now I'm clicking on Upload. Alright, it's flashing. Done uploading. Okay, so it has got the programmer now installed. Good. I think it already did have it, but anywho, now comes the next thing. Okay, so that was all of this. He just said it very quickly, but it was more involved than that. Alright, he didn't even say how to connect the ports or anything. He just assumes all of that stuff. It's kind of ridiculous. Which is fine. I mean, I guess this is... He's assuming people are already well acquainted with how to do things with Arduino, but I'm still a beginner. I need to be able to see a detailed description. He's skipping lots of steps here. Okay. Adding ATTiny85 support to Arduino. This is something I definitely need to do. By default, Arduino IDE doesn't support ATTiny85, so we should add ATTiny boards to Arduino IDE. Open File, Preferences, and in the Additional Boards Manager URLs, give this URL. Okay. I couldn't select it without the leading space, so I just pasted it in Notepad and then recopied it. Alright, so File, Preferences, Additional Boards Manager URLs. Okay. File, Preferences, paste that. Alright, I'm assuming he click OK. He doesn't mention clicking OK. OK. After this is done, open Tools, Board Manager. Tools, Board Manager, it's at the very top, okay. Alright, here's what we were looking for. Stop listening. ATTiny by David A. Mellis, that's the one we just installed earlier. Boards included are ATTiny85, ATTiny45, ATTiny85, that's what we're using. Alright, we're going to install this. Latest version 1.0.2. Alright, if we go to the bottom, I guess it will say installed now. It says it installed, yay! Okay. Alright, pin 2 is what? Okay, SCK. Analog input 1 slash SCK. That stands for serial clock. In the SPI communications language, serial clock, MISO, and MOSI. Input and output from the master. Okay. And let's see. Where's my... Oh, here it is. What the heck? P0 is what? P0 is MOSI. Okay. SCK is pin 2. SCK and ADC 1. That means analog 1. Analog input 1. Okay, we're getting somewhere now. Here's my notes. Actually, I'm going to use a little caret. Oh. Okay. Pin 12 goes to pin 1. Okay. Guys, I'm getting it, man. Which is PWM, comma MISO. What's U block? I have add block and I have some other add block. I thought I had U block. I think I disabled it actually. I can't have too many ad blockers. It didn't work on Twitch for me. Pin 12 goes to pin 1. Okay. Pin 11 goes to pin 0. PWM, AREF, and MOSI. Good to know. AREF, that's very good to know. Okay. Pin 10 goes to reset. which is pin 5. Alright, and of special note is pin 3 not used, analog input 3, pin 4 not mentioned, analog input 2. Pin 0 is PWM, pin 1 is a PWM. Got it. Alright, so that's all the pinouts and all the connections. Okay, so that's what we need to put into our notes. Oh, actually I think we're okay. Okay. Whoops. Oh. What the heck? Alright, so. I also VCC, okay. Well, I would say 5 goes 5, to be honest. Let me verify. Yep, 5 volts goes to 5 volts in these types of situations, not to VCC. So that tutorial was wrong. If you connected 5 volts to VIN or VCC on this board, it would have to pass through the 5 volt regulator, which is the 7805 regulator, and that requires a minimum of like 7 volts to pass through at 5 volts to this microcontroller, so that would screw us. So we need to connect the 5 volts directly. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Alright, 5, 5. Got it. Ground to ground. Uh-oh. Okay. Ground, got it, okay. Pin 13 to pin 2. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Pin 12 to pin 1. Okay. 11 pin 0. Pin 10 pin 5. There's more to it than that though. Okay, relax. Alright, so listen. Wake up. Press OK. OK. Press O. Press comma. Press L. Close quote. Going forward, comma, we can connect to the ATTiny using the same configuration as we used to bootload it using another Arduino as a middleman, Uno, like we did here, comma, or we can connect directly via mini USB and upload sketches, as it should now be detectable via mini USB by Windows now that it has a bootloader installed on it, and it should be able to talk directly to the Arduino IDE now. Okay. Alright guys, I have a little bit of time left. I'm actually gonna start wiring this then. Alright, we gotta knock the rightmost two off of here. Putting angled header pins because I want to keep a more flat profile. Okay. Just cut off two of them that I didn't want on there. Boom. Alright, we should be able to solder these in. I'll need a helping hands to help with that. Helping hands didn't work. Well, I guess I'll just hold it by hand then. Get my soldering station revved up. I'll need my solder, no clean flux, and my solder. Well, I guess we're making some progress now, boys. You know, when soldering starts, things are happening, right? Okay, let me just get some better light going on. So, kind of excited to be soldering. I feel like I'm going somewhere when I solder. Not in standstill mode anymore. I hate when things devolve into research. But we got that done. I mean, we're taking action now. Alright. I did the outer two pins first. Now I'm going to do all the center ones. It's going really well. I told you guys I'm creating a power assist system for my laser printer. The Arduino will control the motor that assists the pickup roller turning. Alright, we got our angular headers on now. Oh man, that's not showing up on camera very well at all. Let me set down my soldering iron. I can turn it off for the moment. Alright. Get you guys a close-up in here. Okay. So that's that. We just got to add 3 more to right here. These 3. And then we'll have all angular headers that are all plug and play. And this will have a nice flat profile compared to headers that go like straight outward. It's a little better. I've seen other people do this. Namely, an inspiration of mine, James Bruton on YouTube. He does it this way on all of his headers. Now, I'm a far superior roboticist to him, but that doesn't mean I can't steal some of his techniques. Okay. Three of these. Okay. We're ready to solder again. That didn't take long. Oh my gosh. Whoops. That was a fail. You gotta really have a good amount of solder on the tip of here. Let's try it again. That worked. All right. P5 goes to Arduino's pin 10. Okay. How do we do that? Let's see. Somehow with these breadboards, I think we can figure something out. Alright, let's say we put these all like this. If we could put this in, hey, what do you know? That's pretty cool, right? I put the headers into the headers. So now we should be able to go male to male off of that with jumper pins. So we don't need to do any soldering. Let's back this away a little bit. And I'm going to set these down. Get this out of here. I'm going to start putting some stuff away to reset. Everything else is plug and play from here forward, I believe. Thanks to that little trick I did with the breadboards stacking. Alright, get rid of this. And get rid of this. Keep this out for now. Okay. So. Where to start? What the heck? I got cords falling out on me. Keep it together, boys. Alright. Pin 5 goes to that's the reset pin. Goes to pin 10. Okay. On our Arduino. Got it. And pin 0 goes to what? Pin 11. That's easy. Okay. And then pin 1 goes to pin 12. Got it. Pin 2 goes to pin 13. Alright. Ground goes to ground. Let's get a black one for that. Okay. Alright, this is coming off the sideways one. Ground goes to ground. Oh man, I need a longer jumper for that. Ground to ground, third one in, okay. Ground to ground, 5 volts to 5 volts. I'll use a red one for that. Want a longish red because it's far and stuff. This one will do. Alright. And then we want a 10 UF capacitor. Electrolytic. Wonder if I have one around. Ooh. I think we're in business, boys. All my hoarding paid off. UF electrolytic, okay, and that's supposed to go from Arduino's reset to its ground. Let me see if I can get this thing to plug in to the breadboard. It's kind of got some solder on it, so it's going to make it a little tougher. Alright, let's see. Hey, it worked. Okay. Man, that breadboard's so darn convenient. That was fast as heck. Totally get it now. Why people bother with breadboards. It's so worth. Wow, I didn't know I had dip LEDs. Sweet. I truly am prepared. Don't even know what I got. Alright, and then let me get a black wire for the ground side of the I guess this one will do. Boom. And I got to take that to ground. There's 2 ground pins. We'll take the second one here. And we need the other side of the electrolytic capacitor to go to our reset pin of our Arduino. That's here. Second one from the top. Alright. We have a proper mess of wire now. But I think we're golden. I think that we are ready to program it now. Okay, so now we need to actually connect up. Let's get this into here. And let's get this into here. Oh, snaps. It's trying to install right now. Yeah. Alright, I do not want to move because these are loose USB connections. Alright. Select ATTiny under Tools Board, then select ATTiny85 under Tools Processor. Tools Board, we select ATTiny25, 45, 85 since we're using 85. Processor, ATTiny85. Tools Clock, internal 8 megahertz. I guess that's fine. Internal 8 megahertz, and then Arduino's ISP under Tools Programmer. Got it, okay. And Tools Burn Bootloader next. Error burning bootloader. Son of a... COM5 port. Oh, thank God. I didn't select the port. Holy hell. Done burning bootloader. Oh my gosh. Oh, snaps. Wake up. Press return. Press hyphen. Press space. Then make sure to select the proper COM port. Press space. Alright. Stop listening. So now we go to File, Examples, Basics, Blink. We change pin 13 to pin 0. Paste it. Paste it. Paste it. Paste it. On. Is a good one. So this middle line. This bottom line is pin 10. Stop listening. Goes to 5. What? Oh. And 11 goes to 0. Holy crap. Hey, I'm interested to know one thing though before I call it. I want to see if I plugged in this little microcontroller now, if the computer will recognize it. That's what I want to know. Doesn't seem like it. Huh. Alright, it's not recognizing it, but I feel like it would. If we... Alright, Windows won't recognize it still. So what that tells me is most likely we're going to have to need to program this thing through the other Arduino as a go-between. The same way we bootloaded it, that's how we'll add programs to it. So let me make a note of that. That's important. After burning the bootloader in this fashion, comma, theoretically, you could connect this device via micro USB to the computer and upload sketches to it, comma, however, comma, Windows would not detect my device for some reason, period. Perhaps the drivers are not available, period. So to get around this, comma, you will want to upload sketches using the same wiring diagram we used to install the bootloader. And once a sketch has been uploaded, comma, unplug the ATTiny85, press delete. Press delete. And plug it into its desired circuitry to test that its program is working properly. Period. This workaround will solve the driver issues with Windows. Period. And connect it to a new circuit that has an LED and resistor set up on pin 0 and has a power supply provided. And verify that it blinks pin 0. Supposing the ATTiny85, press delete, press delete, press delete. Does in fact blink on pin 0, comma, reconnect it to its bootloader installation circuitry and program it in preparation for extensive programming. Which is listed below. Guys, so stop listening. I got done everything I was supposed to get done today, for the most part. We made great progress on the printer. From what I can tell, we can't upload sketches to the ATTiny85. There's some missing drivers or whatever. Unless if we use an Arduino Uno as an in-serial programmer or a middleman. The same way we use the Arduino Uno to install the bootloader onto the ATTiny85, we have to use the Arduino Uno to also install all sketches. So we're going to have to constantly move the ATTiny85 board into the in-serial programmer circuit for our Arduino Uno to be able to upload sketches to it. And then we need to quickly remove it from that circuit and move it over to its actual circuit that we're going to be breadboard testing out its functionality as it pertains to getting it to aid my laser printer in turning its pickup roller assembly, or a power assist functionality circuit. And we'll be able to test that it can read a signal, and when that signal comes in, it will begin turning a motor at a set rate using PWM. And we'll get all that connected, verify it's all working perfectly, verify the motor's turning at the correct speed. We'll tweak the coding until it's just right, swapping the ATTiny85 back and forth between the two circuits, one circuit to program it, one circuit to test the programming. And once we finally get it just right, we will install it onto the printer and connect it up for a live run, transporting all the parts that were in its test circuit over to the printer for a real run. And then because we've tested it, we can pretty much guarantee it's going to work perfectly, and we'll get the motor connected up to a belt and tie everything in really well, and we'll run some prints, and it should make the printer work hands-free. And once we've established that, we can return the side covering onto the right side of the printer and return the pickup roller cover over everything. We'll have to modify that to fit. And then we'll build out a bumper and a bottom support structure to prevent this tray from getting damaged ever again. In the event that we crash into it or fall onto it, it won't break again because we'll make it a lot stronger, reinforcing it in the front and in the bottom. And then we'll be totally done, and we can put back on our towing straps and lift this thing with one arm and set it back on the floor, and then put all the stuff back on the floor that we used to have. We'll take this table back to the room, clear up all the stuff that's on the table, and we'll have our room back to its original configuration, which will be awesome. And so we're on the final stretches of all this. It's looking very promising. It's going to happen before you know it. And this will be my first completed functioning Arduino based project. Completed. Working. My other Arduino based project is a switch mode power supply based on Arduino, which is 80% done. So we're going to have back-to-back Arduino projects finishing in a pretty short succession and marking off some major landmarks for my electronics progression. And that power supply will pretty much mark about the 2/3 mark of my Dustbuster vacuum project, and I'll be making that power supply a few more times for various other projects, such as my CNC machine, my robot, and my welder, and even my welder that's going to be on the CNC machine, which is a separate welder. So we're going to be making a lot of those power supplies going forward. And once the power supply for the robot's done, it's off to the races. We'll be able to then start connecting up motors to that power supply and connecting up the computer to that power supply. The robot's main brains onboard computer. We'll be able to get its main AI engine up and running, and then we'll be able to start installing its sensors and its motors and for its arms and fingers, and getting that arm moving, and then we'll ultimately get it to start being able to do tasks from that point forward. So that arm will begin building more robotic bones and begin building the rest of its own body. And I'll start having it do some basic chores for me as well. Maybe some square cutting, maybe vacuuming around the house. We'll start simple. Maybe have it start doing my laundry. No, it's not gonna masturbate me. I don't like sexual, okay? So we'll get it doing all kinds of stuff. And yeah, it'll build the rest of its own body, and then it'll begin building more robots for me. So it's going to be an exciting time when all that goes down. It's right around the corner. So anyways, guys, have a good day or night. Peace out.